Good day to everyone. I am Janessa Lameda from BA3D. So today I will be present my assigned topics, particularly the quality tools, quality assurance, inspection, statistical process control, and the process capability. First, let's discuss what is quality tools. Quality tools are the techniques, methods, and instruments used to facilitate quality management processes. They are designed to help organizations identify, analyze, and improve their processes, ensuring that the products and services meet or exceed customer expectations. So, ang quality tools is mura siya ang tools and methods nga mag-help sa organizations to manage and improve their processes. These tools are used to find, examine, and fix problems in how things are done para nga ang product and services are high quality and make customers happy. So, muna siya ang quality tools, muna siya ang mga tools and methods nga mag-help sa organizations para mag-manage and para mag-improve ang ilang processes. Next is some of the most common quality tools include the flowchart, check sheets, histograms, Pareto analysis, scatter diagrams, control charts, and last is the cause and effect diagrams. So, flowchart is a visual representation of a process. As a problem-solving tool, a flowchart can help investigators in identifying possible points in a process where problems occur. Second is the check sheets. A check sheet is a simple tool frequently used for problem identifications. Ang check sheets is also mag-provide a format that enables users to record and organize data in a way that facilitates collections and analysis. So, kani siya format might be one of the simple check marks. Check sheets are designed on the basis of what the users are attempting to learn by collecting data. Third is the histogram. A histogram can be useful in getting a sense of the distribution of observed values. It is a chart of an empirical frequency distribution. Fourth is the Pareto analysis. Pareto analysis is a technique for focusing attention on the most important problem areas. Next is the scatter diagrams. A scatter diagrams can be useful in deciding if there is correlation between the values of two variables. And last is the cause and effect diagrams. Cause and effect diagrams offer a structured approach to the search of the possible cause of a problem. So, kanina siya nga tools helps to organize problem-solving efforts by identifying categories of factors that might be causing problems. So, those are the 7 most common quality tools. Okay, let's proceed to the quality assurance. Quality assurance is a systematic process designed to determine whether a product or services meets specified requirements and standards. It is an integral part of a quality management that focuses on providing confidence that quality requirements will be fulfilled. So, quality assurance is muna siya ang method used to make sure a product or services meets certain standards. So, isa na siya ka part of managing quality nga mag-help to ensure that the product or services are reliable and meet the customer's expectations. Next is the inspection. So, inspection is an appraisal activity that compares the goods or services to a standard. It is a vital but often unappreciated aspect of a quality control. Although for well-designed processes, little inspection is necessary, inspection cannot be completely eliminated. And with increased outsourcing of products and services, inspection has taken on a new level of significance. In lean organizations, inspection is less of an issue than it is for other organizations, just because lean organization place extra emphasis on quality in the design of both products and processes. Moreover, in lean operations, workers have responsibility for quality. However, many organizations do not operate in a lean mode, so inspection is very important for them. This is particularly true of service operations, where quality continues to be a challenge for management. So inspection can occur at 3 points. First is the before production, second during production, and third is the after production. So the logic of checking conformance before production is to make sure that inputs are acceptable. And dito naman sa during production is to make sure that the conversion of inputs into outputs is proceeding in an acceptable manner. The logic of checking conformance of output is to make a final verification of conformance before passing goods on to customers. So, inspection before and after production often involves acceptance sampling procedures. Monitoring during the production process is referred to as a process control. To determine whether a process is functioning as intended or to verify that a batch or lot of raw materials or final products does not contain more than a specified percentage of defective goods, it is necessary to physically examine at least some of the items in questions. So, the purpose of inspection is to provide information in the degree to which items conform to a standard. The basic issues are how much to inspect and how often, at what points in the process inspection should occur, whether to inspect in a centralized or on-site location, and thus is whether to inspect attributes or variables. Next is the statistical process control. Statistical process control is a method of quality control that uses statistical techniques to monitor and control a process. By measuring and analyzing variation in the process, statistical process control helps ensure that the process operates at its full potential to produce conforming products with minimal waste. So, SPC or statistical process control is a way to keep an eye on manage a process using statistics. So by checking and analyzing changes in the process, SPC helps make sure that the process runs smoothly and makes products that meet standards with as little waste as possible. So last is the process capability. Process capability is a statistical measure of a process ability to produce output within specified limits. It quantifies how well a process can meet the required specifications or tolerances set by the customers or industry standards. Okay, so once the stability of a process has been established, it is necessary to determine if the process is capable of producing output that is within an acceptable range. So, there are 3 commonly used terms referring to the viability of a process output. First is the specification, second is the process variability, third is the process capability. So, a specification or tolerance are established by engineering design or customer requirements. They indicate a range of values in which individual units of output must fall in order to be acceptable. Second is the process variability. It reflects the natural or inherent variability in a process. It is measured in terms of the process standard deviation. Control limits and process variability are directly related. Control limits are based on sampling variability. Sampling variability is a function of process variability. On the other hand, there is no direct link between specifications and either control limits or process variability. They are specified in terms of the output of a product or services, not in items of the process by which the output is generated. And last is, the term process capability refers to the inherent variability of a process output relative to the variation allowed by the design specifications. So, those are the three commonly used terms refer to the variability of a process output. So, that's all, and thank you for listening.